All right, guys, we are doing trig ratios, okay? You will need to work towards memorizing this, okay? I'm telling you now, you need to work towards memorizing this. I say this, your quiz is on Tuesday. You will not have notes. Your quiz on Tuesday, you will not have what? Notes. Okay? So, here we go. Let R be the distance from the origin to a point on the terminal side of the angle. So we have angle theta here, and R is going to be the distance between the origin and a point, any point.
Is it like terminal? Because it's like an airplane.
Terminal because it's where it stops.
Like flies off the line. Like an airplane.
Sure, if that's what you need else. But that's not why.
It's like the terminal. It's like,
Okay.
Sure. Okay. Whatever you need to do to help you remember. Now, key thing here is that you need to remember that the radius, this R, is describing distance. So your R, no matter what, is going to always be positive because it's describing the what? Distance. Distance. Okay. Oh my gosh.
Yeah.
All right. So if I'm going to a point, points are made up of a certain distance you went horizontally and a certain distance you went vertically. Agreed? Right? So you are here, right?
Yeah.
This is your X, this is your Y, and following that path leads you to your point. If you notice here, what do we create?
Right.
Oh my gosh, a right triangle. Okay. In geometry, you guys worked with certain with right triangles a lot, right? Hopefully you did. Okay. One of your biggest takeaways should have been SOHCAHTOA. Or do we remember that? Is that ringing a bell? Oh yeah, I don't do that. Don't worry. All right, so here we go. No. All right.
Sign up here.
But here we go. So, SOHCAHTOA. Does this look familiar? Now, my teacher probably isn't like the best person as far as how I learned SOHCAHTOA. We did not use it as how other people use it. But here it goes. So sine, here's our sine. Sine was opposite over hypotenuse. Cosine, adjacent. Oh, where's my H? How did the H become an O, guys? I was too. Who did that? Okay, cosine, adjacent over hypotenuse, and tangent, opposite over adjacent. Okay, how did I learn this? Here we go. Some old hippie caught another hippie tripping on acid. I'm just telling you how my teacher chose.
That one lady was out of line, but I remember it.
Yeah. Okay. Some old hippie caught another hippie tripping on acid.
You're allowed to say acid.
Some old hippie caught another hippie tripping on acid.
Like opposite. How is that supposed to?
Okay, just remember where everything is at. So your O stands for your opposite side. Okay, so if I have theta here, so sine of theta equals the opposite over the hypotenuse, right?
Yeah.
Yeah. Opposite. I thought we were gonna say it with me, but no one did. So I was like, okay. Okay. Opposite over the hypotenuse. So looking at my theta, what is opposite of my angle? Y. And what would be my hypotenuse? R. So it's Y over R. Okay.
What does O stand for?
Opposite side. Okay. Cosine. So cosine of my theta. So looking at my theta, cosine is adjacent and hypotenuse. So adjacent to me is what? X, and my hypotenuse is still R. So X over R. The tan of my theta comes from my opposite over my adjacent. So here's my theta. What's my opposite? Y. What's my adjacent? X. So we have Y over X.
Remember it.
Okay. So from here on out, instead of us saying just SOHCAHTOA, whatever, so whatever go. I told you it's not a normal thing for me. My name is Shauna and it doesn't have a W in it. It could be whatever you want it to be. Okay, so Katoa, is that right? I just told y'all what I learned today, so, mine is not normal. But here we go. You are going to have to remember that it's referring to this as y over r. So it's a right triangle drawn in quadrant 1. Do we see that? Okay, and now we're gonna keep going. So these values are our trig ratios that we'll be using for any point given in the coordinate plane. All right, so writing it out, remembering the fact that again, it's based on a right triangle drawn in quadrant 1. This is our theta, this is our r, this is our x, and this is our y. If I am missing anything, whether it's x, y, or r, how did you solve it for a missing side? If I am missing a side, Pythagorean theorem. Do we remember Pythagorean? Okay, normally it would be a squared plus b squared equals c squared. But do we have a, b's, and c's here? No. So our Pythagorean that we work with is x squared plus y squared equals r squared.
That's literally a circle.
He's talking about the formula for a circle. At the origin? Oh, you don't say. Isn't that crazy? Okay. All right, here we go. So Pythagorean theorem, x squared plus y squared equals r squared. That means that if I know x and y, can I find r? Yes. If I know r and y, can I find x? Yes. We get it? All right. Now, our sine, what did we say sine was in terms of this right triangle? What did we say? Y over r. Okay. What did we say cosine was? X over r. What did we say tangent was? Y over x. Okay. These are called their reciprocals. Okay. So it's the flip of it, right? So the reciprocals are cosecant, secant, and cotangent. Cosecant is abbreviated CSC, secant is SEC, and cotangent is COT. Okay. The cosecant is the reciprocal of sine. So instead of y over r, it becomes r over y. Secant is the reciprocal of cosine. So instead of x over r, it becomes r over x. And cotangent is the reciprocal of tangent. So it becomes x over y. As long as I have the values, I am just plugging it into the ratios and simplify.
It's like really dumb, but secant isn't a reciprocal.
You want an S and S?
Like, yeah, but
Nope. S has a C and C has an S. Okay. Key thing, remember that we're going to always simplify. Okay. You're going to always simplify. All right. How do we feel? Gotta have this memorized.
that's what
Doable? Okay. You gotta have it memorized for at least this quiz. Yes.
Okay.
All right. Now we're going to apply it. Are we ready to use it?
Oh, boy.
Here we go. All right. So it says if the terminal side of theta, my theta didn't make it, of an angle in standard position passes through point P, draw and find exact value of the 6 trig functions. Okay. So we have 6, 8. So things we got to remember are where our signs are, right? In quadrant 1, quadrant 2, quadrant 3, and quadrant 4. In quadrant 1, your signs are positive and positive. Agree? In quadrant 2, we're negative and positive. Quadrant 3, we are negative and negative. And in quadrant 4, we are positive and negative. Is that about right? It is right. It's not about. You're like, yes, ma'am. Okay. Oh, yeah, of course. All right. So we have X and Y, right? 6, 8. What quadrant am I going to be drawing this in? 1. So I'm gonna go 6, 8, somewhere in here, right?
Yeah.
I'm just gonna draw a little dot, draw a little line, call a little day. And that's where we're gonna put 6, 8 at. Okay? And now we're gonna go through and find our trigs. But before, step 1 is gonna always to be find any missing piece. What are we missing? Our R. So we gotta solve for R. And how are we gonna solve for I? Pythagorean. Okay? So we're gonna solve for R using Pythagorean theorem. So we have, again, we're using x squared plus y squared equals r squared. We have our x and our y, so we have 6 squared plus 8 squared equals r squared. Still with me? That's going to lead us to 36 plus 64 equals r squared. What is that? 100. 100 equals r squared. What do?
Divide it.
Take the square root. And the square root of 100 is 10. So now we have our radius, our x, and our y. Can I find all trig ratios now? Because I have x, y, and r. So second step is to find your trig ratios. So now we're going to find our trig ratios. We're going to start off with sine theta. Sine is what again?
Opposite over hypotenuse.
Opposite over hypotenuse. So if you need to use your picture, could you? Yes, you could. So what is it though?
8 over 10.
8 over 10. And what do we need to do? Simplify. And what does this simplify down to? 4 over 5. So sine theta at this point is 4/5.
And then we're done here, we keep going.
We gotta find all 6 of them.
6.
Okay? When you have sine, can't you tell me it's cosecant?
Yeah, you just do that.
Cosecant theta is the reciprocal. So if we're 4/5, what is the reciprocal? 5/4. Okay? Yes? All right. Next, we're going to do cosine. What is the rule for cosine?
Adjacent over.
Adjacent. And what am I adjacent to? And my hypotenuse is 10. So we have 6 over 10. And what does that reduce to? 3 over 5. What is my reciprocal at secant? 5 over 3.
So secant is SEC or SCC?
Secant is SEC.
Like E?
Yeah, it's an E. Sorry.
As in like.
All right. Tan theta. What is tangent?
It's
Opposite over 8 over 6. Adjacent.
Or y over x. Opposite over adjacent, y over x, all work, right? What's my y? 8. What's my x? 6. What's 8 over 6?
That's 4.
And then therefore my cotangent is what? 3 over 4. Now you're done.
This is not bad at all.
We're good? We're okay?
We're done. That's it.
Well, we have to learn when it's not as pretty numbers. But, all right, just to make sure we're good, I'm gonna give you 3 minutes to do number 1 on your assignment. That I'm gonna pass out.
Oh, why don't you?
We have another assignment.
This is some easy prep.
Okay.
I'm going to pass out. The reason why I wanted to pass it out is because I messed up and I wrote 6.4. Please cross out the 6.4 and put a 6.3. Okay.
That's negative 1. Does not matter.
What do you mean? No, it matters.
Doesn't matter.
It matters. It matters. Welcome.
So then it's.
I already got one of them, huh?
Well, we're gonna get some crushed.
I already got one. No, it's the angle, it's just acting up. It doesn't like it. Alright, so y'all agree number 1, making sure you can follow the process. T is a point. Why?
I messed up my bed.
Right.
What's on about that?
How did you mess it up?
That's all I need.
What? What?
I'm all
Oh,
Why are you still wobbling, Miss Jones? Your ankle is okay.
no, it's not.
Oh, God,
Okay, so moving on. Now, again, if your terminal side of your theta in standard position passes through P, all these good things, right? Now we're at -4 comma square root of 2. Okay, so -4 tells us that we're going to be in either quadrant 2 or quadrant 3. The square root of 2 tells us that we're in quadrant 2. Agreed? Because I have a negative and a positive. So I'm somewhere in here. Doesn't really matter how perfect or anything, but this is where I'm at. All right. So I know that here's my theta. I went -4 square root of 2. Agreed? Yeah. All right. So step 1 tells me to find my R. So I have to find my radius. And I find my radius by using x squared plus y squared equals r squared. My x squared is going to be -4 squared. My y squared is the square root of 2 squared equals r squared. A negative times a negative is a positive. A square root times a square sets it free. So now I'm at 16 plus 2 equals r squared. What is 16 plus 2? 18. So I have 18 equals r squared. I'm going to take the square root. 18 is not a perfect square, but 18 can be simplified. Is this correct?
Yeah.
Yes, 18 is made up of 9 and 2. So I take the square root of 9, square root of 2. And what do I get? R equals 3 square root of 2. So I now have my R. So I now have R is 3 square root of 2. Now I'm going to find my 6 trig ratios. So,
Let me know.
yes.
So okay, so I know it's 3 of 2, but why is it 3 of 2?
Because 18 isn't a perfect square, but when I factor it, I get 9 and 2.
But if you factor 9, it'll be 3 and 2.
And I can take the square root of 9, which is 3, but can I take the square root of 2?
No.
No. So I leave it in the house. So now it's simplified.
So like if it was 10 instead of 9, it would be 5 with 2.
It would just stay square root of 10 because I can't break 10 down anymore.
Okay.
Okay. So now we're going to do sine. Sine of theta is my y over my r, right? So whether I want to think about it y and r or however, but here is going to be opposite over hypotenuse. Agreed? So we end up with square root of 2 over 3 square root of 2. What happens? What happens to my square? They cancel out. So I'm just left with 1 over 3. So sine theta equals 1 over 3. Therefore, what is my cosecant theta? 3 over 1, right? Which is just 3. Are we still good? Okay. Now we're going to do cosine theta. Cosine theta is my adjacent and my hypotenuse, or x over r. Agreed? So we have -4 over 3 square root of 2. Oh no, we have a problem. The problem is we have a radical in the denominator. Okay, we cannot have a radical in the denominator. It is not rationalized. So we have to rationalize by getting the radical out of the denominator. Okay, the only way that you can get a radical out of the denominator is by multiplying it by itself. So we're going to multiply, and we end up with -4 square root of 2 over 3 times 2. Because a radical times itself sets itself free. Okay, so what ends up happening here? 4 and 2 are going to do what? Well, they simplify, right? And I'm left with just -2 square root of 2 over 3. That's my cosine theta. This guy. That's 1/3, it's 3. Okay. Your reciprocal, go back to where you started. Your reciprocal is gonna come from here. If you start here, you're gonna have to ratify again. And you don't wanna do more than you have to, right? So go back to where you initially started to find your reciprocal. What do we call the reciprocal of cosine? Secant. So my secant theta equals this reciprocated, which is gonna be 3 square root of 2 over 4. So there's my fourth.
The negative?
Yes, I dropped my negative. I'm sorry. Thank you.
That's only when it's the denominator, right?
Yeah.
Yeah.
I don't want that reason.
Okay. All right, we have 2 left. So we have tangent left. Tangent is what?
Y over X, opposite over the
Opposite over adjacent. So
Y.
tangent theta
Y.
equals y over x. So square root of 2 over -4. Do I need to do anything?
No.
Nope. Because my radical's where? Already at the top. But the cotangent theta, I end up with -4 over the square root of 2.
You can't just make it 1 over -4, or I mean, 1 over -2,
Where?
for 10, the regular one, yeah,
No, because it's square root of 2 and that radical protects that 2. Can't touch it.
okay.
Good question. All right, so I'm gonna ratify
I know this is a good question. You have-
and we get -4 square root of 2 over 2. What happens to -4 over 2?
Oh,
What does that equal? It equals -2. And there's my 6. -4 divided by 2.
Oh,
President interruption.
All right.
This first announcement is for teachers.
negative.
Hold on, Sam. I'm listening.